I'm going to go ahead and introduce all of our panel members here. We have such a big panel that we don't even have a table for them. So this is Kevin, our last presenter, Kevin Berryhill from Provost Pritchard. He presented on multi-contaminant treatment. Tali Lopez, a water quality manager for Cal Water, presented on TCP removal. Lisa Miller from Golden State Water, water quality engineer, she presented on arsenic removal. Issam Najam, who gave us a wonderful chemistry tutorial on chromium-6 chemistry and treatment. And Ethan Brook and Tara Henry are both are going to be in the afternoon session, and Ethan's going to be presenting on low-cost options for THM removal, and Tara, what are you presenting again? Nitrate. Nitrate removal, and then Eugene, who is our friend from the Division of Drinking Water, who was, again, the inspired party who instigated this whole event. So I guess I will be microphone man, because this is the only one we have that's mobile. So I'll just open up the floor. Does anybody have experience with bacterial, what was that? Bacterial growth at on the effluent side of chromium-6 treatment? Okay.
So my experience is actually on the effluent side of nitrate treatment, but with also strong-base anion exchange. So one of the issues that we ran into was actually, it was on the regen side, the salt. We had switched vendors, and the NSF-approved salt we were receiving actually experienced growth in the salt tank. So we switched back to the other salt, but once the growth is kind of in the media, it's a little challenging. So we did a lot of just getting runtime on it. If you have to go the disinfection route on strong-base anion exchange resin, it's expensive and challenging. So just running it as much as you can sometimes can clear it up, but you need to address any underlying issues that are creating that contamination. If you have still an oil lube well pump where you might be getting occasional heterotrophic plate count hits in the well, then that would be something you could address. Switching to a water lube usually will clear that up with a cleaning and things like that. So.
A quiet crowd. I'll go ahead and ask one I wanted to ask to Kevin, but I was curious, with so many chemical additions and water chemistry modifications in that last scenario, how you were able to satisfy yourself and the system that corrosion control wouldn't be an issue post-treatment.
Well, corrosion control is always challenging because I've used the term the black arts before, because there's different types of corrosion and the chemistry isn't completely understood in a lot of cases. At a minimum, the first step would be something like there's a computer model, a spreadsheet-based model you can use to at least look at the calcium carbonate precipitation potential and the Langmuir index. That's not really enough. So we look at the water quality more generally to see if we're changing, the ratio of sulfate to chloride. We look at how the pH is changing. I will say, in my experience, you really do need to bring the pH pretty much up to where it started. I mean, we talk about a lot of chemical addition there, but really the TDS of the water is fairly high to begin with. It wasn't like there was a huge percentage jump in TDS. It's really the pH adjustment that's usually the problem.
Okay, good. For those who've done pH adjustment in any situation, you've always heard about using carbon dioxide to lower pH and then presumably blowing it off to get it back up. Has anyone actually done that, and has that been successful?
In my prior career, we did do that in like cooling tower water, where we had to, we brought gaseous CO2 into the water, and it was successful, and it was. Yeah. I think for for well sites and water treatment, I think you'd have to have like a pretty large volume of water to consider something like that.
David, I think actually my experience is a lot of people that measure the pH of groundwater most of the time report the wrong pH of groundwater, because by the time you collect the sample and you measure that pH has gone up just from handling it to bringing it up to the atmosphere, let alone those that send a sample to the lab to get the measurement done. So it is quite effective as an engineered system as well. Controls of it is typically the challenge, and what other precipitation happens with it, because most of the time you try to get that aeration through a high surface area system, like an air stripping tower, but that also promotes precipitation that otherwise would not happen in the bulk water. So it's a bit of a tricky from a precipitation perspective, but from a CO2 stripping, it is quite effective, yeah.
So we looked at this a little bit for finished water at a treatment plant using equipment that we oftentimes field for THM volatilization. We did some lab work and found that it looked like it would go, but we did not have the confidence to really put it forward into the field. So this is definitely something of interest, I think, in the greater treatment community.
I'd like to also add something. If someone uses carbon dioxide to depress the pH, then if they go to a caustic to raise the pH back up, there's a problem in that chemistry balance, because when you add carbon dioxide, you depress the pH, but you don't depress the alkalinity. You don't lower the alkalinity. Then you go back with caustic, bring the pH up, bring up the alkalinity. So now you ended up with the same pH water maybe, but a significantly higher alkalinity than previous water, and you can get unintended precipitation problems. So if you're going to use caustic, I think mineral acid is the way to go. If you're going to use carbon dioxide, then air stripping afterwards would be the right way to go to.
Can I ask a question of the panel?
Let's see what I've got. So,
I do have a question for Eugene, actually. I'm not going to throw you under the bus, Eugene. In all honesty, with the small water systems, the residuals management does seem to be a massive issue, and it's a big cost driver. And I'm wondering if there is any possibility of, now that there's more statewide interest in our disadvantaged water systems, to work with the regional board and the Division of Drinking Water together to maybe look at more reasonable limitations and restrictions on water systems. For example, can we get by with bentonite ponds? Something that for the most part prevents any percolation into the water versus expensive concrete or flimsy polyethylene lines. Just as an example, I don't know that it ever has happened where the Division of Drinking Water and the Regional Board have worked together to try to figure out how to make these treatment plants more viable.
So I think with our move from CDPH over to water boards, it definitely has helped that line of communication, and I think it is the goal of both all the water boards, the state and the regional water boards, to solve this water quality problem. So I think as we look at more of these solutions, there'll be more collaboration between the regional boards and the Division of Drinking Water in dealing with some of these issues. I think there's a lot of opportunities there, and I think we will be able to sit down with their local office and probably down in the Fresno office for you to see if we can work out some alternate solutions to the traditional approach, because there's definitely a lot of water quality problems in the Central Valley. And the residual disposal, it is the key driver, and then see if we can have a common understanding on both sides, so to see what we can do.
Quiet group. Let me see. So one of the thoughts that I had as we were going through a lot of these presentations is we are talking about problems that were related to groundwater, which is the prevailing source for small systems. And we're also talking about contaminants that are common to smaller systems. But a lot of the solutions still seem to be pretty large scale. So I'd like to, if anybody has any feedback on like ideas about scalability when we're talking about, you know, dropping from 4,000 or 40,000 service connections down to several hundred, or if that's just the elephant in the room here.
I think I can share some thoughts with that. So I think from the approach right now for the Division of Drinking Water, we recognize a lot of these technologies you cannot scale down as easily. And actually for like some of the systems, it just doesn't make sense because having a 20 connection system versus a 4,000 connection system is the same control system behind the treatment. And so it becomes very, even though it's technically scalable, it's just cost prohibitive. So I think a lot of the approach right now is really to see if you have multiple systems around, hopefully we can consolidate them. And even if and then be able to regionalize the system to be able to build a bigger treatment plant to serve all the systems so that we'll be able to scale it up, to have more connections, make it the economies of scale, and having one treatment plant maybe serving multiple systems. So I think there's a lot of thoughts behind that to see how we can scale it down or by regionalizing, by reducing the number of the water system so that to kind of like meet that threshold. And for those that kind of like missed this morning's presentation, I think looking at the compliance data from us it's like water systems less than 500 service connections seems to be the threshold of like systems smaller than 500 has the most difficulty in coming to compliance. That's like 90% of our systems have violation is below 500 service connection. So even multiple systems, maybe about 100 or something, we can group them together and be able to increase it and then be able to build longer pipelines to connect them up. That maybe make it more viable. So I think that's some of the approaches that is in discussion by program. So hopefully we'll be able to take that approach.
So I'm an equipment manufacturer and an inventor, and from our perspective, you know, this is a question that we struggle with a lot. You know, how do we address this huge part of the market where there are really significant water quality problems, but there is not a lot of money to pay for the equipment? And the reality is, you know, some technology that we create scales very nicely, and we can come up with something that's very small scale and that will work financially for us. In other situations, it's not technically feasible. And so that leaves us in a tough position to try to address different segments of the market.
You know, you use the term scalability. I'm not sure that's the right term for it because, you know, we scale up from pilot to full scale. So from a size perspective, technically, as Gene mentioned, it is scalable. It's the affordability aspect of it. And, you know, consolidating, I can see the administrative consolidation. It is the physical consolidation that is really the biggest challenge of this. And I just, good luck with that. That's all I'd say.
Yeah, the only thing I would add is, number one, the only technology that I regularly encounter that does economically scale relatively well is activated carbon, because it's passive. It's a kind of a dumb process without a lot of moving parts. But for some of these small systems, they're industrial small systems. Commercial properties, a warehouse, for example, is one of the small systems, permanent drinking water systems. And in some of those cases, I think point of use and point of entry really do have a place. You know, you don't have showers to worry about. You don't have the property, the legal aspects of trying to implement a point of use project on a residential development. I think that's a good solution for those, but those are the low-hanging fruit. Once you get into the residential communities that are small, it's a huge problem.
I came in a little late, so I apologize, but I was curious, how many of you, with all your specific technologies, have current projects that are installed that serve communities with fewer than 500 connections? And then it's a two-part. Do you mind I'm curious, does everybody? Okay, super, thank you. And so this is an implementation question, which in my view, it's really challenging sometimes to get real numbers on operation and maintenance costs. And so have you looked at sort of predicted O&M versus actual costs? And for the actuals, including the waste disposal, for your installed systems here in California? And then if you have, did you compare those, and what did you find?
It's a great question because, there's the upfront cost of the equipment, which is what many different procurement strategies are based on, and then there's the ongoing operational cost, which oftentimes can far outweigh capital over the course of time. And so, to be perfectly blunt, I haven't gone back and looked at what we're predicting versus what we actually see. As a vendor, we tend to move on to the next project, but I think it's a really important topic and one that deserves attention.
Okay, we have looked at that, occasionally in some situations, but I did want to speak to our TCP GAC treatment systems. Where we're operating right now with these systems is probably at the highest cost that we're ever going to operate those systems. And we're really expecting, as we are able to implement a different type of GAC media that can be reactivated, that those costs are going to come down significantly, and we may even, be able to experience a little bit of longer runtime with our treatment systems. So it's something that is kind of unique to, at least with the TCP treatment. Anything else? Yeah.
It is a terrific question, and one of the problems that we face, as designers of systems, after it's built, there tends to be a very limited administrative managerial structure with these systems. And so frequently, if you're just relying on them to track their costs, and if you were to make a phone call or go visit them, it's very difficult to ascertain the costs. And I think this would be a great subject for some kind of a funded study to provide some financial resources for someone to go in and audit these systems and to document the real costs that they're experiencing. Because with the exception of the private water purveyors like California Water Services that maybe have the resources to go in and do a little more thorough investigation, your communities of 500 and smaller don't. That's been my experience.
So I'll say a couple things on that. The project that we'll be talking about this afternoon does have that as a specific stated goal and outcome of the project, but so far we're still on the beginning side, so we've only calculated what we think it's going to cost. But from a practical point of view, some strategies you can think about implementing are really tight contracts with your vendors. So if they're providing operations and maintenance and the ongoing services, you can really be very specific about what that should cost you on an ongoing basis. And I would definitely recommend you look into that. And like Kevin mentioned, the pilot studies is a really terrific tool for ensuring that you have pretty good O&M costs going in. A lot of vendors are very anxious to sell you equipment, and they aren't so, they're not on the hook necessarily for if they're wrong about what your ongoing O&M costs are. So it's really important that the utilities do everything they can to accurately assess that from the beginning, pilot studies, and then once you've done the pilot studies, to make sure you can hold the vendor accountable to the extent possible to ensure that you're actually getting that cost or better in the long run. But there have been multiple examples of failures across the state from O&M. O&M costs is just higher than the system anticipated. So they got the capital installed with the grant funding, and then they just stopped operating because the system didn't know how much it was going to cost. So.
If I may also, one of the greatest uncertainties in estimating the O&M cost is the labor cost. It is thrown out as a number. The problem is twofold. One of them is it is a big part of the annual O&M cost of many systems. And so a small error in the projecting that labor cost can mean a significant discrepancy in your overall estimate. But also, what we find out is that labor cost is a specific system culture impacted as well. You can have the same process operated at two different systems, where on one side, they try to do it with half an FTE. On the other side, they have 1.5 FTE. For the same treatment technology. It's because the way the the philosophy of that system is versus the philosophy of this system. When it's a significant part of the O&M cost and you have this much of a difference with an utter inability to predict that difference, it really puts a lot of doubt in the ability to project O&M cost. Other than the material replacement, labor cost in some of the numbers that I've worked with can be as much as 75% of the total O&M cost.
Lisa, I know in your presentation you talked about a differentiation in the bed volumes that you were anticipating versus what you saw. Can you talk about how that impacted your costs? Or?
Yeah, as I mentioned in my presentation this morning, we have some absorptive media processes to remove arsenic, and our original estimates, I don't know exactly what the original estimates were in terms of the number of bed volumes, but I do know that when the treatment systems first went into service, we saw significantly lower bed volumes than originally anticipated. And as Tara mentioned, I think some of that was overestimation on the part of the vendors. But that did, of course, add to our own O&M costs. Doing the changeouts much more frequently added significantly to our costs. And so we ended up looking at other treatment alternatives at that plant site to kind of help reduce some of that O&M cost to try to bring it back down to something more reasonable for us.
Something I've recently encountered on a couple projects I think is relevant for small systems is sometimes we look to proprietary technologies to try to keep the O&M costs low, very specialized technologies. And one caution I would offer is some of those manufacturers don't last very long. And so with small systems in particular, putting in a highly proprietary process is risky in that if that company goes bankrupt and stops supporting that technology, you're putting that small system in a horrible position. And everybody in the room is probably thinking of one or two. I was just out in another system, Old Basin Water System. They've been gone long enough, I'll name names. And they're not around to support their system, and now somebody else that had a pretty innovative ion exchange process. They're out of business. And I'm familiar with a water system that had just put one of their systems in but hadn't had their startup training. And they were left hanging with equipment, but no training or operations plan or anything along those lines. So that's another caution I would offer, is be very careful and make sure there's a darn good reason before you invest in somebody's highly proprietary, highly innovative.
Good point. So we're wrestling with that very fact right now as part of the Prop 50 project, where we'll talk about this afternoon, and that's really grant money to bring nitrate treatment to disadvantaged communities. And it had started with one of those companies you referenced was going to solely supply that equipment, and it was pretty simple to get there until the bankruptcy. And then we had to really step back and specify that equipment and look at what it really means. And the trade-off between operational sophistication and the O&M cost savings versus the reality that these utilities likely can't operate them it's a really interesting place to try to find where that is. If you put all these extra moving parts on and then you don't have the operator or the manual, they're really no good to you and they cost more. So it's a delicate act. And any sort of thoughts on where to go with that? Because I mean, you talk about 1.5% savings in brine at 25 cents a gallon. It's a real number, but you got to ask what it's worth to get there. So important piece.
So that makes me think of a question is, when we evaluate these technologies and some of the cost graphs that were up there, they looked at kind of a combined cost of amortized capital plus operational costs. And with the intensive focus that's going to these systems that are perpetually out of health-based violation, is there opportunities for more intensive capital investment to bring down your long-term operational cost or complexity, since it seems like capital funds are not necessarily easy, but easier to come by than long-term operational costs?
Yes, sometimes you can do that. You can sometimes spend more on the capital side, and I think for the small systems, it's absolutely worth looking at that. But the next challenge you run into is that it still may not be enough to lower the O&M to make it affordable. So the calculations we have for the small systems that we're looking at for the Prop 50 project, it's exactly that. We can increase the amount of capital. We can consolidate the management of these systems so they won't be physically consolidated, but they will be, sharing a brine delivery contract and sharing a waste pickup contract and sharing an operator. And those things bring down the costs, but when you run the numbers, it's still unaffordable. So, yes, you can do, sometimes that can get you there, and sometimes it doesn't still.
I think with the approach we're going on is it's a two-pronged approach. I think for all the state funding projects, the capital, we do encourage if it can help reduce the O&M. And I think right now we're looking at a lot of the dialogue in the water boards is looking at what's affordable rates. So there's workshops that's being set up. And I think it's a combination of raising the rates to what's affordable to the community and then find out how we can supplement the additional O&Ms to bring them into compliance and having safe water. So I think we are stuck in that dilemma right now. It's just kind of, even if you spend a lot more, it's still unaffordable. Now, how do we fill that gap? And I think that's where the dialogue is right now.
I didn't have the time to highlight that difference in the cost that I presented on Chrome 6, but when you're looking at the 3 removal systems, that approach very much favors the coagulation filtration process for that one reason, that out of the average number that I presented, which was about $200,000 a year, 140,000 is labor, just again to emphasize the point. Why? Because it has no resin to replace. It's chemicals, labor, and sewer discharge. So, but it is the highest capital process. And so I think there's a lot of room to go in that direction. And my experience is going in that direction means moving away from proprietary processes and moving towards more conventional processes that have less replaceable components that need to be replaced for treatment performance.
Well, I'll push back against that a little bit. We in my company, we've spent a lot of time and R&D money to create, highly efficient processes, and we have not felt particularly well rewarded in that expenditure by the marketplace. It makes it tough for me to, go to my management and continue to make this case that we need to continue to push and find ways to drive down O&M costs if during the procurement process there's no real ability for that to be a benefit to us.
Maybe a little different direction in the answer, but one thing I would say is a lot of these projects are grant or loan funded, and one thing we can do is make sure, not talking about sophistication here, but I'm talking about durability. Make sure we're designing and constructing something that's robust. Don't put in PVC when steel's the longer lasting material. What you're trying to do is avoid having maintenance and repair costs down the road go through the roof. Because the state, I think it's right, is willing to spend a little more money on a grant for a capital project if it results in a long-term, more sustainable solution for the system. And so, I would say try to go out of your way to make those smart decisions and write the specifications. And when it goes out to bid, make sure you're getting the high-quality product, the stuff that's going to last for years and it's not going to fall apart in the first year.
I don't know if this is an answerable question or not, but with the emphasis toward higher capital cost improvements in order to drive down longer-term operational costs, one of my concern would be how do you design into that system future unknown MCLs coming online or something like that, that all of a sudden you have to 4 or 5 years later redesign part of that system.
It's tough, isn't it? I mean, that's tough. It's tricky. And there's no way to predict the future, right? We're all in that same boat together. But I think when you have some level of confidence that the equipment that you're purchasing is going to, you're not going to be in a situation in 3 to 5 years where you don't need it anymore. If you need to add more, that's certainly different than if you're trying to buy a highly technical product that's got this possibility of malfunction, right, or bankruptcy. So try to say this more clearly. If you're in a position where you can spend a little bit more money in the near term to spend a whole lot less money in the future, how do you structure your procurement to allow you to do that? And isn't that kind of a good idea?
I think quickly to wrap it up, I think it's for the technology-wise, majority of the contaminant treatment technologies can remove all the contaminants to non-detect. So I think the chances of the MCL being moved down very quickly is not likely because we have different process where the detection limit we need to set up will be quite a few years before it will suddenly change an MCL. So it's not going to happen overnight, but majority of technology right now, people are only treating partial flow and then blend around to keep the cost down. So if the MCL does go down, maybe you just need to add an additional parallel unit, then the treated water will be able to meet a new goal if there's one.
I'd be curious, since most of you have been involved in small water systems, there's one aspect of the project which is just to make sure it's technically feasible. There's another aspect to it is there is, with small water systems, there just seems to be kind of a distrust into treatment or what's coming out of their tap, their involvement in projects. What are some strategies you guys have used from a local perspective or a community perspective that have helped move projects forward? And have been successful?
I do agree that that's a challenge, and even doing public outreach is a bit of a challenge too, because a lot of times, you can have public meetings, and sometimes you get good attendance, but sometimes you're presenting really important, what you think is really valuable information, and you have like 3 people in the room that are like the same 3 people that always go to the city council meeting or something, but you don't have the whole community there, so it's really difficult to have that dialogue. But usually, they'll show up for rate case stuff. So if you're raising the rates enough, then they come, but then they're not happy. They're not there because, they're really excited about this project you're doing. They're there because they're mad that you're raising the rates. So it's definitely a dialogue and trying to get people to understand that and explain why it's important is challenging, but I think bringing in regulatory partners can be very helpful so that they can explain, you don't have to take my word for it kind of thing. Like, can you have EPA come in and help? Can you have DDW come in and help and explain why we want to make sure that we're meeting this maximum contaminant level and why it's important and what we're doing to bring down the costs? And presenting to City Council, presenting at Rotary, presenting it, making sure that the key community decision makers really understand the process you're going through and what you're trying to do to keep costs down and to meet the water quality, regulations. But yeah, it's not simple, and it's difficult to go out and engage with the community as well. It's challenging to get their attention.
One of the things that I encounter, and frankly, that's the first communication that we have, is that the fact is putting any treatment on a groundwater well compared to no treatment is going to be a sticker shock that one needs to get over first. And then you get into the discussion of optimization and, finding the right solution, things like that. But it is a very difficult thing to overcome. The fact that you've ran this system with just chlorine to the well for decades, and now you have to incur millions of dollars for whatever treatment system you're going to put in, is a psychological barrier that is very difficult to overcome. But that is, in my opinion, that's the first conversation that needs to be had before we talk about any treatment. It is that barrier from virtually no cost to, oh my God, cost.
Any other? I did have one question I wanted to put to Eugene before we wrap up, or anybody else who wants to jump in. But I was pleased to hear that the representative from the governor's office is taking water quality issues so seriously. And he pulled out a number of $150 million that they're making plans to raise. So I don't know where that number came from, but let's just, supposing $150 million materialized for the governor's office and hypothetically involving DDW to address out-of-compliance systems. Presumably a lot of that would go towards capital, but I'm a little bit more interested in kind of like how the framework for operation and maintenance comes out of that. Because if we're trying to spend that much money, is there some kind of training system or employment system, or like where do the FTEs come from to run all these systems that we could conceivably be putting in if we raise the money?
Oh, you want to do it? Okay, we'll tag team. He'll let me know if he doesn't like my answer. So the Prop 50 project we have that we'll talk about this afternoon, and Heather will be getting a lot into some of the policy details that are proposed now. But some of the recommendations we'll be making out of our Proposition 50 project is actually on the policy side. And of course, we can't make the state do anything. All we can do is, have some recommendations. But one of the recommendations that at this point we would like to make is around the O&M and, trying to keep costs affordable for systems so that some systems in situations may qualify for subsidies on the operations and maintenance side. The experiment that we're trying with Prop 50 is just a shared operator so that it's a contract operator. Not every system's necessarily going to employ their own full-time operator. And what that allows for is the systems to really have someone that's qualified, that's spending all their time doing operations and maintenance on different systems, and could be a higher grade certification. So I think that that's one thing that really we're going to need to look at more as whole state is kind of where we can share resources instead of each little system being so siloed. So some of the recommendations we'll be making are to consider looking at larger systems, not only this kind of DAC and SDAC qualification being hinged on 10,000 people, because some of these systems are just barely over 10,000, but they're still very economically disadvantaged. So how could we address that better? How can we address better the differences in regional economics? So if you're a small system in LA or in the Bay Area, you could possibly not qualify as DAC or SDAC, but that doesn't mean your system isn't poor. You can have people that are actually effectively very poor because the area's housing costs are so high. So by looking at more of a regional income scale, we might have these other systems that potentially could qualify. So I think there are a lot of considerations that could go into this, and then you have the whole issue of what is affordable, which definitely hasn't been solved. There are a lot of calculations you can do, and sometimes it's gonna come up as affordable, and sometimes it's not, based on the different metrics. So
I think one more thing, it's right now for the Division of Drinking Water, I think we are open for all ideas. So I think there are opportunities for input. I think directly reaching up to the higher management in our division will be great. And also water boards, they have monthly board meetings, and I think there will be an opportunity for you to comment, to provide suggestions. I think there are many avenues. I think there's not a set plan right now. So if the money does come down, but I think there's no spending plan that I'm aware of.
All right, I think we're going to dismiss and let our panelists get some lunch. I'd like to invite everybody else to come back after lunch. We're going to be resuming at 1:30, but so thank you all for coming.